Hi, this session is presented by the Kubernetes IoT Edge Working Group. This is about using Kubernetes for edge applications. I'm Steve Wong, a tech lead for the working group. I work on Kubernetes and a few other open source projects as an employee of VMware. Today I'm joined by...
Hi, I'm Dejan Bosanac from Red Hat, software engineer, and also a co-lead of this working group, also interested in a lot of IoT and edge for the cloud projects. Yeah, back to Steve.
Okay, let's move on. So we're going to give contact information and a link to the deck at the end, but here's the agenda. I'm going to start with a really quick definition of what we're defining as Kubernetes at the edge within this talk. Kubernetes has obviously been hugely successful in applications calling for orchestration of containerized apps in large clouds, but edge can be a little different. We're going to cover what Kubernetes can do and what it can't at edge. Hopefully you'll like the talk, and if you do, we're going to wrap up with details on how you can become a member of the Kubernetes IoT Edge Working Group, where we host ongoing discussions on subjects like this talk. When we say Kubernetes at Edge, what are we referring to? Well, some examples are listed here. At past KubeCon physical events, we've taken audience polls to identify the popular use cases. And in those polls, the leading use cases have been retail, telco, industrial IoT, smart cities, and video capture with image recognition. But there's a lot of additional use cases that fit underneath this same edge umbrella. There's a lot in common across these applications at edge, but the important question is actually, what's in common with the original Kubernetes use case of container orchestration for a large data center hosted cloud? Let's start by observing that containerized packaging of apps can be really valuable in both a centralized cloud and at edge locations. And with edge, just like cloud, you might have a lot of these things to manage. So just like a large data center hosted cloud, you need something that offers automated management at a huge scale. It's interesting to observe that Kubernetes isn't just a solution for container orchestration. If you were an early participant in this field, you know that back in 2015, there used to be many other open source container orchestrators, and that somehow Kubernetes managed to move from the back of the field in the horse race up to the lead where it sits today. Many things factored into the success of Kubernetes, but I'm going to nominate two key aspects that I think really apply in edge use cases. First, Kubernetes has a fantastic architecture. It's based on a declarative API, and it's readily extensible. If you look at history, take Border Gateway Protocol, for example. BGP has been around for decades. The internet's changed a lot since the 90s when it came out, but BGP is still as popular as ever. And I suggest that its long life can be traced to a clean, extensible architecture together with a community that allowed it to evolve. In a few minutes, we'll get into the Kubernetes architecture and extensibility in particular. But that isn't the only aspect that made Kubernetes attractive. The second factor, and perhaps the most important, is the healthy ecosystem, which is spinning off collateral tools, what the CNCF calls the cloud native landscape. You know, edge applications are going to need far more than just containers. I'm talking about logging, network management, even things like available training materials and experienced people and vendors. Writing software on an island just isn't efficient. So Kubernetes has some great attributes for edge, but are there any offsetting limitations? We need to observe that edge locations are not large data centers. A public cloud is generally going to have a big mix of high and low priority apps, huge amounts of compute, storage, and other resource. And this allows high priority apps to enjoy very elastic scalability. A cloud data center can generally add new capacity in days to weeks. Edge locations are really different. They're going to have no trained staff, and in some cases have hardware life cycles of a decade or more. The nature of networking at edge can be quite different. It's not all IP-based protocols. Low bandwidth and intermittent connections are normal. Scheduling of apps to the hosts they run on is different. In a large public cloud, the compute resource is mostly interchangeable. Sure, you might ask your orchestrator to scatter a clustered service across different failure domains, but within a single failure domain, you probably don't care where your container runs. Edge apps can be tied to particular locations and particular physical I/O devices, so a scheduler might need an awful lot of coaching to do the right thing. Then there's the big issue of physical security. There might not be any. So to compare central cloud to edge, they're both managing a lot of things. Both benefit from containerization as a road to portability, and both benefit enormously from a community driven by a standard API and collateral tools. But some important differences to consider are resource constraints, differing network demands and constraints, and security challenges. Let's consider how we might apply Kubernetes at edge. Suppose we take one monster-sized central cloud-hosted Kubernetes cluster with each edge location running as a cluster node. Can that work? Maybe. And I think it's fair to say that I know of people who are trying it and reporting that it works well enough to be useful. But for others, there are going to be issues. For example, what if I need more than 5,000 nodes, the current Kubernetes upper limit? Yes, I could go multi-cluster. Some use cases might have enough resource at the edge locations to run a full Kubernetes cluster at each location. Can you federate over 5,000 clusters? I'm not really sure, but I know it would be challenging. And running a full cluster at each edge location is going to take resource that some of you may not have. And suppose these locations are unstaffed. How do you provision and maintain the platform below Kubernetes, the OS, hypervisor, and hardware? Some edge use cases clearly don't have enough resource to run a full Kubernetes cluster. Some can't even run a single cluster node. There are devices that don't even run Linux and thus will never host a containerized app, at least in the form of Docker containers. Also consider, how do you get the apps to edge? To some extent, existing tools like an image registry could address this, but taking the aerial view, you actually want a broader solution that can distribute not just Docker images, but other classes of apps and even data packages to edge. So it's clear that plain Kubernetes isn't going to solve all your edge problems. So let's ask, what can we do about this? What if we could extend Kubernetes? And what if we could help it out with some additional open source tools? Let me start by describing the Kubernetes control plane architecture, because this is the basis of its extensibility. The Kubernetes API has a declarative, not an imperative philosophy. This means that you tell Kubernetes your desired goal and it figures out how to get there. You don't feed it step-by-step instructions. So what's a controller? Well, it's just a snippet of code that looks at the declared desired state. It then looks at the state of the world and compares. It tries to reconcile these by making the state of the world look like it should according to the configuration. If the controller fails or it can't fully realize the desired state, it continuously and relentlessly retries. If it takes time to make stuff happen, the controller can be patient and diligently work. This is a very stable distributed system pattern. Actions are idempotent and self-healing. So if something goes wrong, the controller will fix it. If you change the desired declaration of state while the controller is working, it can change course and work towards the new goal. Picture this like the thermostat in your house. Set a desired temperature, go to sleep, everything's going to be fine. Contrast this to a wood-burning fireplace of 100 years ago. That's an imperative API. too cold, you go outside and get a log. How well does that scale? What if the person had to manage 100 fireplaces in a huge building or many buildings on a college campus? Compare this to the declarative nature of thermostats and you can kind of get the idea of, you know, the advantages of going with a design based on declarative with controllers. Internally, Kubernetes is built on these controllers, a lot of them, as a recurring aspect of the system. The placement of containerized apps on worker node servers is handled by just such a controller. But the interesting thing for IoT and Edge is that you can write your own custom controllers for managing and controlling whatever you want or need. You can extend Kubernetes, and this is called a custom resource definition, or CRD for short. When you install one of these, it extends the API with the etcd database holding the settings using that declarative model. The declarative part of this is called a CRD, and they work with a piece of software called a controller. And by the way, the controller can be hosted on Kubernetes, but doesn't have to be. You could host it externally. Now, what if we used Kubernetes CRDs to manage low-level devices and apps on those devices, even when the constraints don't allow Docker packaging? You can run Kubernetes orchestrated containers where it makes sense, the upper half of this diagram. But if you reach a point where the available resources can no longer support a Docker container, you can continue to use Kubernetes as a control plane for all aspects of your distributed system. Where the dividing line occurs might vary depending on your use case. You could even influence the line by using specialized Kubernetes distributions like K3s or micro K8s that are made specifically for low resource environments. Or you could go with stretch clusters where edge locations run individual Kubernetes worker nodes instead of whole full clusters. Regardless, there's always going to be some point where the standard managed containers can't go. You know, take the Arduino platform, for example. It doesn't even run an OS, so it's never going to run a Docker image, yet this is a popular platform for running IoT. This diagram is intended to point out that a properly designed CRD, with a properly designed CRD, the Kubernetes control plane could go all the way down to the bottom, limited only by the need to have some form of connectivity. And that connectivity doesn't have to be IP-based. Translation could be performed to some alternate protocol by a gateway tier. At this point, I'm going to turn it over to my esteemed colleague to dive deeper into CRDs and some collateral open source based tools for Edge.
Thanks, Steve. So Steve introduced us to the term of custom resource definitions, and basically with the custom resource definitions, we can model out any resource that our applications, IoT or Edge applications, needs to use, and that it's out of the scope of the typical Kubernetes resources, right? But one more thing that's missing there is a controller loop that will operate on top of these custom resource definitions. And when we pair the CRD with a control loop, we're basically getting operator that lives in its own reconcile loop and try to do the right thing for us. So the same pattern as we saw that Kubernetes itself uses is used here. So the operator observe the current state of the system and the desired state of the CRD, analyze the differences, and then act on that, trying to get the real world according to our definition, right? So now we'll go to a couple of demos and projects that we found in the communities that apply these patterns to different IoT and Edge use cases, just to give you an idea how these can be applied to the IoT and Edge domain. So The first one is the Kubernetes of Think session that happened at the FOSDEM that basically just demos this kind of architecture. So here I wanted to show you like a simple CRD and how it can look when it doesn't apply to a typical Kubernetes resource like a pod and things like that. So here we have a device, and this device basically have a specification for a couple of inputs, and we also see here that each CRD has its current status. It's empty here, but this is where we're getting the status of the current system. If you go into the CNCF landscape, we have a K8s project, which is a big part of our working group, and the K8s tries to provide a way to run IoT workloads on a constrained devices. For that purpose, it defines its own custom controller and the core modules that talk to each other and can work in a constrained environment where you don't have enough resources on the edge to run the full kubelet and all the things that the Kubernetes nodes have, but also dealing with the network restriction between the control plane and the edge. But one of the interesting things here is that K8s also defines a lot of, so to say, higher level abstractions for dealing with the IoT and edge applications, and they're going into the way of introducing the CRDs for defining devices and manage them for the cloud. If you follow the link that we have on this slide, you will see the examples of these CRDs and how they can be used to properly manage devices by the K8s. One more interesting project in this space is Eclipse Hono, which doesn't work on the terms of devices, but more on the applications and microservices that you would like to run on the edge sites. And in a similar fashion, they are going into the direction that you can define these microservices and applications as CRDs and apply their custom controller operator logic on these in terms of deploying those microservices on the appropriate edge nodes. So here we defined how we can model things outside of the Kubernetes and new abstractions that we want to apply. But for some IoT and edge locations, maybe we can think about the other way around. So maybe our pod specifications is all we need. So we can define our containers that we want to run on our edge node and the edge site. But we really don't need the whole control plane of the Kubernetes to do that. So if you want to do something like this, so maybe you can think about going into the direction to use something that's called like a static kubelet, and try to install only the kubelet on the edge node and deploy manually and directly your pod to the node without any overhead of the Kubernetes control plane. And there's a session that you can see at this link, which goes into the detail about how you can achieve something like this. Of course, if you go into this direction, you will need still to do some provisioning on your own, so you still can't get away from the control plane, right? Either you will do it manually, so you will be the control plane that will install things and take care of things. But in most cases, you will use something as something like Ansible or Ignition to do basic node provisioning on the lower level. And maybe you use some of the GitOps tools from the CNCF landscape to basically distribute this pod specification to a large number of edge nodes if that is needed. And now we are coming to the section talking about how we can go beyond Kubernetes. So as we can see, Kubernetes gives us a good framework for resiliently managing our infrastructure and the workloads running on that infrastructure. But we still need to define some of these workloads and how these things specifically for some of the use cases. IoT, Eclipse IoT and Edge Native working groups are specifically focusing in these areas and defining the projects that can run on Kubernetes and try to solve some of these common issues. So I will quickly here go to a couple of these projects and show you what you can do with them and how you can form like a big picture and create a truly IoT or edge clouds on top of the Kubernetes. So first one that we'll mention here is Eclipse Hono, which tries to define a connectivity layer for IoT devices connecting to the cloud. It tries to define a commonly used communication patterns between the devices and the cloud workloads in terms of sending telemetry data from the device to the cloud and sending commands and controlling these devices from the cloud. The point here is to define this interaction in a uniform way so that it can be used over a variety of protocols, and also to use everything that we know about building a scalable systems and in Kubernetes and provide us with a way to do this for millions of devices and thousands of different kind of applications living on the same infrastructure. But connectivity is just the first part. We can call it like a cloud gateway into the IoT platform. What we need behind it is what's usually in the industry called the digital twin. So what we want to do is to provide a developer, a cloud developer with a well abstracted, well-defined abstractions for the different kind of devices, right? So we don't want a cloud developer to deal with connectivity at all. So we want to deal with the device state, the current state or the desired state, and provide it with the APIs that it can do it in a similar way, of how it would do it for any other kind of like a web resource, right? So Eclipse Ditto is a project that defines the digital twin in this context. And the final piece of puzzle here is how we actually manage all these devices connecting to the cloud, right? So basically we said that we can send commands using the Eclipse Hono from the cloud to device, but what kind of commands and what will listen to those commands on devices and how we gonna support updates of software on devices and doing different kind of updates. So Eclipse Hogbit is a project that defines all the tools that we need for that. It can again scale to the millions of devices and a lot of software to do that, but also define more complex scenarios for that, like rollout strategies and error detection rates, so that you can be able to confidently update millions of devices in a secure fashion. And one thing to tie all these projects together is something what we call the cloud to edge package. So each of these projects like Hono, Ditto, and Hogbit all have their own Helm packages, so they're very easy to install in the Kubernetes environment. But we also defined a cloud to edge package, which with basically func command, as you can see on this screen, you can install the whole cloud IoT platform consisting of these projects, all configured to work together in the coordination. And we have a lot of so if you look at it like this, it's positioned as a cloud platform, right? But more and more we're discussing at how we can bring some of these functionalities closer to the edge and make a more edge style deployment of these functionalities in different environments. But this is something that we'll probably talk about in the future, or talk about during our regular calls. So this is again the call out to join our regular meetings, which are happening every other Wednesday. We have two different time slots. One more appropriate for a Western world, for US, and one more adjusted for the APEC, so that everybody can have their own appropriate time slot. So that's it. Steve, do you have anything else to add at the end? You're muted.
No, that was great. I think we're staying online for Q&A, so feel free if anything came up to ask us questions. And if you're watching this on the recording, join the group. We've got an active Slack channel. You can ask questions there. And we also have a member-driven agenda on our meetings. So if there are any topics that are of interest to you, I'd invite you to first join the group, then go and nominate topics for an agenda at a future meeting. And the leadership of this group will engage in best efforts to get speakers on topics that are driven by membership.
Okay, yeah, thanks for watching this, and let's go to the Q&A.